So we'll do the smiley cases. Cases 4. When is it smiley? When little a is a positive number. When little a is positive. For ax squared plus bx plus c. Okay, so if a is positive, we know that we're going to see something like this. A smile. What happens if the x-axis is down here? Well, we know what we get. We know that we get two complex solutions. And if it were an inequality, that means that this could go one of two ways. What do you mean, Chris? Let's suppose for a second, I'm going to move this around. Let's suppose that we call this a name of a function. Let's call this function little g of x. So our quadratic, our happy smile, is called little g of x. Well, there's certain cases that could occur. What do you mean, Chris? Well, you could have little g of x is greater than 0. Where does this occur? Well, if you look at the graph, all the heights of this function, little g of x, are always greater than 0 because they're above the x-axis. So what does that mean? That means that all the real numbers work. Any x that's in the real numbers works just fine. Okay, well, what about where is g of x greater than or equal to 0? Well, all the heights are still greater than 0, and none of them are equal to 0 because they're all above it. So it's the same thing. All real numbers for x are going to work. What if we flip this around? Where is g of x less than a height of 0? Ooh, looking at that graph, none of the heights are negative. There's no height that drops below the x-axis. What does that mean? That means there are no x's that are real that would make this work. So we would say there are no real solutions. No real numbers of x will make that graph go down below the x-axis. Same thing if we made it a less than or equal to symbol. No real solution. Yeah. So this is one of the cases. That's why graphing it is so imperative. If you can graph it visually, if you know where the x-axis hits or doesn't hit in this one, it allows you to answer this question immediately. Yeah. Let me show you here a couple of other cases. I think the most intuitive case to me after this one is when you have a graph, there's our smile again, but the x-axis hits in exactly 2 spots. Okay, so this one has a little different implication. And I'm going to try to combine the 2 cases here of g of x being greater than, and I'm going to put a dashed line, or possibly equal to 0. No, actually, I take that back. Shame on you, Chris. Don't try to take a shortcut. Let's take it case by case. Where is g of x greater than 0? Well, keep in mind, we know that it hits the height 0 right here and right there. So right at these spots, we know it's 0. Let's pick some letters for those. Oh, you know what's appropriate? Let's call the first one x sub 1. So the first solution is x1, and the other solution is x2. Those are the x values for which the height of that hits the x-axis. It's at height 0. Where is this thing above? Well, you can see the function is above it right here, and the function is above the height 0 right there. It's positive in height. Where is that occurring? That's occurring, we're going to color this in with, let's go blue. All the x's that are right here cause the heights to be positive. All the x's that are over here cause the heights to be positive. So as we keep moving in both directions outward, those x's cause heights to be positive. What does that mean? The solution would be for this one, from negative infinity up to x1, but not including x1, union that with x2 to positive infinity. So we're writing the blue dashed area, that blue kind of highlighted area, as an interval. That's the solution for being positive. If we change it ever so slightly, where is g of x greater than or equal to 0? There's only one minor difference between this, what we just wrote, and the next thing that we're asking for. The only difference is we'll go from negative infinity up to the x1 solution. But we're allowed to equal height 0. Right here at x1, it is height 0. So we're allowed to include x1. Why? If you plugged that number, x1, into the original function, it would spit the height 0 out. So the only difference is we're including our solutions of x1 and x2 in our interval notation. Any questions on these right here? Anything that we've done so far? These get a little weird. Okay, no questions just yet? All right. Guys are doing great. Hopefully you're understanding it. No questions sometimes means you don't understand. But hopefully you guys are getting this. You guys are bright, so I have a lot of faith in you. All right. What if this is less than? Be very careful. The less than case is over here. The height of the function is less than or negative in height. That occurs for any of the x's that are on this part. That's where those negative heights get generated for these x values. So the solution for being less than 0 represents any x's in this stream that spit out these negative heights of the quadratic, which means we can go from x1 up to x2, but we don't include the endpoints because the endpoints create a height equal to 0. And our inequality says we are strictly less than 0. If we change it, you know what's going to happen. You can feel this coming. If we slightly change it and make it an equal to case, the same little zone of x1 to x2 works, the only difference being you don't have parentheses because you're allowed to equal height 0. So you're allowed to include x1 and x2 in your solutions. Yeah. So this is the way it works if we hit the x-axis twice. It's a little more complicated. And the last case, the worst case in my opinion, and the one that's least common, is this. If you've got a quadratic that just touches in one spot, what this means is the solution here of hitting the height 0 happens exactly at just x, x1. There's only one spot that it hits at. And we'll talk about multiplicity of a solution, but it's not needed yet. So one solution, one x value that works. This gets weird. Where is the height strictly bigger than 0? Where is the height strictly positive? It's positive everywhere, except right there it's at height 0. So all of the real numbers work for the x's except x1. So In interval notation, you would go from negative infinity up to x1, but don't include it, union x1 out to positive infinity. Everywhere works except at x1, so we exclude x1. Here's what's weird. If you said greater than or equal to 0, excuse me, all the heights are greater than, and right here the height is equal to a height of 0, which means all real numbers. All the real numbers of x work. Where will it get weird? Less than 0. Where is the height less than 0, strictly less? This has no real solutions. Kind of a weird case. None of the heights are ever lower than the x-axis. What about where is it less than or equal to 0? Well, we know that it's never less than 0, but is there a case where it's equal to 0? Yeah, it's equal to 0 right there. So it turns out the only solution is when x equals x sub 1. So the worst one is when it just touches only at one spot. You got to be real careful what you're asking. But these are the 4 inequalities, the 4 cases that can happen under any one of these circumstances. So this is how this works out. Let me show you how the steps are going to work when you do the